ಅಯ್ಯೋ ಸ್ಟಾರ್ಟ್ ಇದು. Okay, now let's see time response of control system. Okay. First, let's see the definition of control system. Time response. Definition of time response. What is the time response? The response that is given by the system, which is a function of time. It is the response given by the system which is the function of the time. That means what? What response we are getting within the stipulated amount of time. Such response we call it as time response. Okay. Now let's see the transient response. Okay. Transient response. Transient means what? The output variation. You know this type of variations we will get. Now, when I give an input signal, we will get some variations here. This is called as transient response. How it going to vary? Okay, this is called as transient response. So, how do you define transient response? The output variation during the time. It is the output variation during the time. Everything we are measuring with respect to time here. Okay, during the time it takes to achieve the final value. To achieve the final value. That means what? Whenever I'm giving some input, with respect to the input, some response I'm getting. That means some output I will get. And then what is transient means? How much time the variation response it is taking to achieve its final value. The time that is required to achieve the final value. Okay. It's also called as transient response or transient period. You can also say it as transient period. Okay. Next. The transient response usually it's given by an exponential or an oscillatory, that you know. Okay. The transient response, anything will be given, any response will be given either in an exponential form. See, this is my reference. Okay. This is my reference value, and when I am giving some input with respect to time, this is my step input, step reference step input. Okay, with reference to time, step input I am giving with respect to time. The C of t is here, and this is called as this period. We will call it as transient time. This period is called as transient time. Okay. And this period from where it is started to become stable, we call it as steady state. It has become stable. Okay. Then The difference between this reference point and what we are getting, we call it as ESS, steady state error. This is with respect to exponential wave. This type of waveform, we call it as exponential. Exponential. Okay. Now how we are going to write it mathematically means the time, mathematically it is represented as limit t tends to infinity at c of t is equal to 0. This is how mathematically it is represented. Exponential wave. Next let's see the oscillatory waveform. How the oscillatory function will work. Okay. Now this is my c of t. This is with respect to time t. Reference is the step input. Now what? It's an oscillatory signal, right? It's going to oscillate like this and going to become stable. To become stable after some time. Okay. Now this difference we will call it as ESS, steady state error. This period of oscillation we will call it as transient time. And the time that is taken for it to settle down, we call it as settling time or steady state response. Steady state. It is trying to become steady. Okay, state. It is going to settle down. This is a step input. That is my reference input. Okay. This is all about steady state response. We are going to see what is this, how much time it is going to get time taken for the system to stable. Okay. This is about oscillatory wave. Whatever we have studied, this wave is called as oscillatory response or oscillatory waveform. Okay. Next topic is, next heading what we are going to study is standard test signal. Study of standard test signal. Standard test input. Standard test input we are going to study. Okay. There are different types of standard test signals, but here we are going to study only with respect to the three standard test signal. First one is step input. First standard test signal what we are going to study is step input. Okay. This is also called as positional function. Positional function. Let me see. We'll see the graph for it, how it is represented. X-axis will be time t. R-axis means y-axis will be r of t. And we are going to give a step input. Okay. This is it. Now let's see how we are going to represent it using mathematical formula. R of t is equal to this magnitude is considered as A. R of t is equal to A for t value greater than or equal to 0. And it is equal to 0 for t value less than 0. This condition we are going to see. Okay. Now, if If your A was equal to 1, that means what? If your magnitude is equal to 1 or if your amplitude is equal to 1, then we call this as unit step function. And we will call it as unit step function. Okay, it's also denoted as U of t. Okay, now let's find out its Laplace transform. Its Laplace transform is given by, see, if R of t is equal to A, then Laplace transform of that is nothing but R of S is equal to A by S. If A was equal to 1, then your R of S is equal to 1 by S. This is about the standard test input signal. Standard test input signal step. First step we studied. Okay. Now let's study for